conductive or non-conductive. Now let us discuss about the transport arc. In case of this, the arc is maintained between the electrode, that is negative polarity, and electrically conductive workpiece, that is a positive polarity. Note that only electrical conductive workpiece can be machined or cut by transferred arc system. The arc hits a coaxial flowing gas and maintains it in a plasma state. The electrothermal efficiency is up to 85 to 90%. PSC system can deliver up to 1000 ampere at about 200 volt. That should be a DC supply. Okay, the flowing gas pressure may be up to 1.4 megapascal, resulting in a plasma velocity of several 100 meters per second. Higher the gas flow rate, more will be momentum of the plasma jet. It will ease out the removal of molten material from the machining zone. The plasma jet is constricted by the flowing gas, which acts as a cooling agent sandwiched between the nozzle wall and our plasma jet. So in case of plasma arc system, the material may be removed either by melting or by melting and vaporization both. Okay, in either case, the material that is in molten state or vaporized state is blown off from the machining zone by high velocity plasma jet. Okay, so this is a flow about the plasma arc system. Let us discuss the elements of plasma arc system. Now the important elements of plasma arc cutting system are power supply, then gas supply, cooling water system, then control console, and mainly plasma torch. Now we'll concentrate on the plasma torch. Okay, so in plasma torch, there are many torch designs which are practically used. Okay, for example, you can see first one is the air plasma torch, then oxygen injected torch, dual gas system, and last one is the water injected torch. Now we'll discuss one by one. First is air plasma torch. Okay, so it's a detailed figure I have shown in this figure, which is a construction of this air plasma torch. So this figure I have taken from the one book, that is Gary Benedict book. We'll discuss this. This plasma torch uses compressed air as the gas that ionizes and does the cutting. The air is to be used, and that should be uncontaminated. The nozzle of this torch may result in premature failure because of double arcing. Okay, which is I have not shown in figure. Okay, so arcing between the electrode and nozzle, and between the nozzle and the workpiece, that is a double arcing. Air plasma cutting results in a high degree of tapered and high degree tapered machining surface. Okay, so zirconium or hafnium, okay, that is which use electrode life up to 2 hours of cutting time, okay, are used as a electrode material in this case. Okay, because of their high resistance of oxidation, and because of poor oxidation resistance, tungsten electrode does not last for more than a few seconds. To avoid oxidation of electrode or to enhance the life of the electrode, oxygen injected torch is used. Okay, so let us discuss that oxygen injected torch. So it's a schematic diagram I have shown here. Now this oxygen injected torch uses nitrogen as a plasma gas. Okay, oxygen is injected downstream of the electrode. However, it lowers down the nozzle life. This torch gives high material removal rate and poor square squareness of the cutting edge. This is commonly used for mild steel plate cutting. The presence of oxygen in the air helps in increasing MRR in case of the oxidable material like steel. In case of certain ferrous metal, cutting speed is increased by about 25%. It is possible because oxygen back up the exothermic burning of oxidable metals. Okay, so this is about the oxygen injected torch. Now, third is that is gas system or dual gas plasma torch. Okay, which uses one gas, that is a nitrogen, as a plasma gas, while another gas as a sliding gas. So you can use oxygen or carbon dioxide or argon, hydrogen, etc. Secondary or sliding gas is chosen according to the material to be cut. Okay. The secondary gas system helps in maintaining sharp corners on the top side of the cut edges. Okay, so you can see in this figure, I have shown the this dual gas plasma torch. Okay, so this is the construction. Let us discuss the last part, that is a water muffler or water injected torch. So here water that is having the pressure near about 1.2 megapascal is injected, okay, radially or vertically to constrict the plasma. A small quantity, about 10% of water vaporizes. Okay. This thin layer of steam constrict the plasma. Okay, and also insulate the nozzle. Nitrogen at about 1 megapascal is used as a plasma gas. To avoid double arcing, the lower part of the nozzle is made of ceramic. Water constriction helps in reducing smoke, enhancing the nozzle life, reducing and limiting formation of oxidize on the cutting edge of the workpiece. In some system, sliding gas or secondary gas or water is given slowing motion. Okay. Now, water muffler here use is a device that produces a covering of water around the plasma torch extended down to the work, helps which helps in the reducing smoke and noise. Water mixed with the dye also absorb part of the ultrasonic rays, okay, which is produced in the our plasma arc cutting. In some cases, water table is also used to reduce the level of noise and extent of spark. Water below the workpiece quenches sparks and damps sound level also. So underwater uh, plasma arc cutting systems are also available, which effectively reduces the noise and smoke level. So these are the elements of the plasma arc cutting system. Let us discuss the performance of plasma arc cutting system. As the surface speed during this plasma arc cutting is increased, volumetric MRR is found to attain a maximum value and then start decreasing. Plasma arc cutting has been employed to cut material as thick as 150 mm. The cutting speed is affected by the thickness, okay, that is a small t, of the material being cut, type of material being cut, and the current being used for the uh, cutting. Okay, cutting speed, we can say capital yes. Okay, we have to measure in meter per minute, is found to decrease with increase in thickness. So we have the one formula, S is equal to 25.4 upon T. Okay, where you can take current as a up to 500 ampere. The tolerance obtained are poor and depend on the thickness of the material being cut. Okay, for example, the tolerance value of plus minus 0.8 mm may be achieved if thickness less than 25 mm. Okay, and plus minus 3 mm if thickness is greater than the 25 mm. Okay, width of cut is also quite high, that is a 2.5 to 9.5 mm, and taper depends on whether flooring is used or not. Okay, surface finish of the cut edges ranges from 5 to 25 micron. Thickness is governed by the material thickness. Okay, plasma system, in that type of material being cut and cutting condition, that is also important. It ranges from 0.75 to 5 mm. It should be noted that the approximate performance of plasma cutting system increase in power requires a corresponding rise in glass flow rate. So these are the performance about the plasma cutting system. Let us discuss last point, that is the applications. Multiple torch system is used for simultaneously cutting varieties of the shape from one plate. It is also commonly used for preparing ends of the pipe before welding. Again, to achieve a bevel cut on the end of pipe, mount the torch at fixed angle and rotate the pipe under the torch. Okay, so CNC, that is a computer numerical control plasma cutting system, also available in the market. They are useful for punching type of operations as well as for shape cutting on light duty plates. Okay, which is made up of stainless steel, aluminum, and copper, which are difficult to machine by oxy-fuel system. Oxy-fuel system can cut the plates up to definite thickness, beyond which only plasma cutting system can do the job. Okay, in case of thick plate, PAC is much more economical than the oxy-fuel system. In case of cutting of a groove, its shape and size are governed by arc power, transverse speed, angle, and height of the plasma torch. In case of electrical uh, non-conductive material using non-transferred arc, material removal rate is low. Okay, so plasma has also been employed for turning of difficult to machine materials. Plasma torch is mounted tangentially at about 30 degree to the workpiece. Attempts are only being made to develop successful underwater plasma machining system, although associated with the low speed. Okay, so these are the some applications of plasma. Thanks for watching this video. Thank you.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in the comment section. And if you want more lectures, then please do subscribe to our channel. Thank you.
So this was my recorded lecture. So for time being, I have shown that lecture because today at start the strength of student was very less. Okay, now I wanted to show one that video regarding. Mm, sure.
ஆர்கான் இந்த மாதிரி ஏதாவது ஒரு கேஸை நம்ம எடுத்துக்கலாம். இந்த கேஸை
will become electrically conductive or ionized. Probably the gas inside a fluorescent or neon light bulb. Lightning is an example of plasma on a larger scale. If you're in the metalworking business, you've heard about plasma cutting systems. Plasma's combination of cut volume, productivity, and versatility make it one of today's most popular industrial cutting processes. But first, what is plasma? Plasma is often called the fourth state of matter. Let's take a look at the three other states we're all familiar with: liquid and gas. The difference between these states is their energy. When you add energy to ice in the form of heat, the ice forms water. If you water vaporizes and becomes steam. But what happens if you add more energy? If you heat 11,000, steam would break when would be electrically conductive or energy gas. Very high temperatures electricity almost in the plasma probably light is an example of plasma on a large and much larger. Our sun it has remarkable. Specific shape is also a bit like a metal in that it easily conducts electricity and produces and responds to magnetic fields. Because of these unique properties, plasma can be tremendously useful, which brings us back to metal cutting. A better idea is, let's see how it works. Here's the inside of a plasma torch, the kind typically used on cutting tables. Gases provide us, in this example, a second inert shield gas is used to protect the workpiece and blow off melted metal. Electricity supplies the energy needed to turn the gas into plasma. The greater the current, the hotter the plasma. A specially engineered nozzle and electrode constrict and maintain the plasma jet, concentrating it into a small area so it can be used for cutting. When the operator is ready to cut, a start signal is sent to the DC power supply. A circuit temporarily connects the nozzle to the positive side of the power supply with the electrode at negative. Next, a high-frequency spark ionizes the gas and makes it electrically conductive. This creates a current path between the electrode and the nozzle and forms a pilot arc of plasma. The workpiece is connected to a ground through the cutting table. When the pilot arc contacts it, the plasma arcs transfers to the workpiece, melting the metal. The high-velocity gas blows the molten material away. And that brings us to the end of our brief journey into the fourth state of matter, brought to you by Messer Cutting Systems and our friends and partners at Hyper.
Welders generally need to do a lot of metal cutting in preparation for welding. Plasma cutting lets you really zip across a piece of material, speeding the work and decreasing the operator's fatigue.
This is plasma cutting.
While it's certainly possible to do freehand cutting with a plasma torch, you can often get greater accuracy by using a guide. For repeated cutting of complex shapes, you can make a simple guide from a non-flammable material. So here's a pattern used for plasma cutting that I've cut out of hardboard. These can only be used for occasional cutting, but for a few parts it works quite well. So the way this pattern was made was actually from a drawing, and I prepared this drawing in a special way because the opening for the window in the pattern is larger than the finished cut will get. That's because the cutting tip on the plasma torch is 3/8 of an inch in diameter. So this outer line is spaced 3/16 out from the inner line. Also, the outer line of my pattern is 3/16 of an inch in from where the finished edge will be cut on the part. So here's the pattern. We'll get this clamped into place and then use the plasma torch to cut all around this part. So you can see just how fast and efficient the plasma cutting process is. It's a super speedy way to cut metal, and it leaves a pretty darn good surface. But one of the real beauties of the plasma cutting process is that you can do extremely intricate freehand cutting when you need to. Many artists use this process to create complicated cuts in a variety of materials, with results that are often striking.
Okay, so this is about the today's lecture. In the next lecture, again we'll discuss the in detail about this plasma arc machining. Okay, so thank you very much. So I have noted your attendance from your name, and now you can leave the meeting, no problem.